50%, sir. In second case, charge will be divided on the right.
Yeah, it's the same thing. Decrease by a factor of 2. No, you understand. You understood this is the same question. These two questions are same. You understood that, right? Got it? Okay, this one. You understood the question?
Yes, sir.
So what is the answer?
I was having a lengthy calculation for this question.
Actually, this is a conceptual question. It's a theoretical question. You don't have to do any calculation. Without any calculation, you can get the answer. If you have two masses, M1 and M2, and both are falling down, but the acceleration is same for both. So the time taken for you to reach, to travel a particular height, will it be same or different?
Same, sir.
Yeah, so that what is the answer?
But here they for electron, electric force and the weight will be downward, so it will take lesser time, sir.
No. There is no gravity here. Gravity is neglected. For electron, okay, the electric field is upwards.
So
okay.
Electrostatic force will be downward.
So acceleration is downwards. For proton, okay, the electric field is downwards. So acceleration is also downwards. So both are same. And the acceleration, is it same for both?
Same only, sir.
Because acceleration is E into E. Here also E into E. Okay, so correct option is option D.
By M only, no, sir. Mass.
Yeah. Oh, hold on. Yeah. You're correct. Mass of the electron. Yeah, force is same. So acceleration of proton is smaller than. So the time taken by the proton will be more. And you have to find how much. Force, yeah. Electron. See, what is the correct option they are given?
One minute. They have to calculate that the mass ratio, I think.
What is the correct option?
Yes, sir.
So the time taken for the electron is less. That's why I got it.
Yes, sir. Because that the acceleration is more. No?
Yeah, fine. Force is same, but the acceleration is force by mass. So the acceleration of electron is much higher compared to proton. So the time taken by the electron is much smaller. so smaller. Okay. Fortunately, if it's at 5 times smaller, 10 times smaller, then it's difficult. You have to calculate. Actually, this time ratio will be the ratio of, what is the ratio of mass of electron, mass of proton? 1800, right? Is it is the ratio of mass of the proton by mass of the electron approximately? Yes or no?
I don't know, sir.
Okay, something like that. So the time of electron to come down will be 1800 smaller than time for proton. These things you should remember. For exams, it will be useful. This is a standard thing, right? Mass of proton, mass of electron. Okay, done, no?
Okay.
Okay, two metal spheres of radius r and other. Okay, two metal spheres, one of radius r, other one 2r, have same surface charge density. That important. Yeah, this problem also we solved similar to this one yesterday or day before yesterday. Can you try this one? Got the answer?
No, sir.
So
Charge will flow from smaller sphere to larger sphere.
yeah, so what is potential? Potential is Q by R, right? So the smallest field will have lesser charge.
No, smallest one will have more charge. Sorry.
Potential is Q by R, no?
Yes, sir.
So Q1 final. So this thing is smaller. Usually smaller will have lesser charge. So the charge will flow from this to this. Okay, and the charge is like and Q initial and Q1 and Q2 are known. One is the surface area, that is 4 pi r square.
Sigma 4 pi r square given by 2.
This is 4 pi r square, 4 times 16 pi r square. So it is become lengthy calculation. So this Q1 plus Q2 should be equal to Q1 final plus Q2 final. And then this, you have two relations and two unknowns. Two equations and two unknowns. And the two unknowns are Q1 final and Q2 final.
Okay. Um, Q2 final will be 2 times Q1 final.
Got the answer?
Q1 final is equal to 25 plus sigma sigma minus 20 by 2 times Q2. Q1 final is equal to 5 by 3 times the initial one, sir. Q2 final will be 10 by 3 times of Q1.
Sorry. Sigma 2. So this is what? Not right. I should. So what is the correct option? Check the answer. Your mic is off.
D, sir.
B.
D.
Okay, I made some mistake then. Q2 is 4 pi r square is so 16. So pi r square so 40 by 16. 40 by 16. Sorry, I made a mistake here. It's 10 by 2. So it's no. Sorry, 5 by 2. Okay, option 1 is not true.
I got the answer.
Okay. See, the first one is, this is correct, no?
No, sir. 5 by 3. Yes, sir. 5 by 3 times.
And sigma 2 is, Q2 is twice of Q1. So it's 40. But, oh, I left this 3 factor.
Yes, sir.
So it is 5 by 2. So it's 5 by 6. Yeah, correct.
Sir, you left that 3, sir.
Yeah. So it is 5 by 2 into 5, 1 by 3. So it's 5 by 6. Okay. So this is actually a lengthy problem. So I have to do it quickly. So first thing, the concept has to be clear. So you have to draw these pictures, otherwise you will make mistakes. So this is the first situation. So on the QI, I called it QA initial, and this is QA final. So the constraint is QI initial charge is conserved. So initial total charge and final will be the same. And then after connecting, the potential will become equal. That means that this is the second equation. Okay, so 2 equations and 2 unknowns. That you know relate the Q in terms of sigma. Clear, no?
Yes, sir.
Okay, this we already done.
Which one, sir?
This one, the toy car charge to use on a frictionless base. The force and the velocity increases from 0 to 6 in 1 second duration. At the instant, direction that means the car continues to move for 2 more seconds under the influence of this field. The average velocity and average speed per car is. Okay, try this one. The level automatically goes down. Huh. Okay, done.
No, sir.
First, you have to draw the figure. This. As soon as you read the question, you have to draw a figure like this. A toy car is moves. Okay, first the velocity increases from 0 to 6 seconds. So this is 0 second and this is 6 seconds. Sorry. The velocity increases to 6 meter per second in 1 second duration. So this is 1 second then. At that instant, the direction of electric field is reversed and the car continues to move for 2 more seconds. These are already done in the first class or something. Of this field, the average velocity, average speed over time is. So this will be 2 seconds then, and this will be 3 seconds. You remember this thing I did in the first class or second class? Yes or no?
Yes, sir.
So this is the velocity time graph. Because it's from 0 to 1 second, this speed is increasing from 0 to 6. This is given in the question. After that, saying the direction is reversed. So the direction is reversed, the magnitude of the acceleration is same. So the slope magnitude will be same, but the slope sign will be changed. So here, if it is theta, means this angle will be 180 minus theta, or this angle is theta. So slope will be negative of that. So if it takes 1 second to rise from 0 to 6, it will take 1 more second to drop from 6 to 1, 6 to 0. Because the slope is same, just the sign of the slope is different. And after for 1 more second, it will continue on the negative side and it will become -6 here. Okay, so average velocity means integral v dt. Average velocity is integral v dt divided by the total time. Okay, and average speed is integral mod of v dt by time. And this area and this area are equal and negative. So to find the average velocity, I will take only this area. That is half into base into height is 6. Divided the total time is 3 seconds. So it is 1 meter per second. This is the velocity average. And speed average will be thrice of that because this I will take mod. So this here will become positive. So become speed average will be thrice of this one. Correct option is option B.
Yes, sir.
This I already did.
Yes, sir.
Okay, these are the questions he gave me.
Right. Only more questions around 20 or 22.
No, these are the only questions he gave because previously whatever I gave, they are solved.
No, you can check on your phone, sir.
From phone only I got this one. Okay, I have some other questions. Just check your WhatsApp. All the questions are covered.
No, sir.
Tell me the date. Your mic is off. Your mic is off. What is this going on? Tell me the date of the question. When you
70.
check the questions. Which one is not done? Everything is
22, 22, 77, 83,
okay. Second batch. Okay, I have not seen this one.
22.
See, these things are not difficult. Okay, I'll do it next time. Okay, because I have
If you
to.
just give me, then I will do it by myself.
What?
You will just Give me the hint. I will do calculation.
This level goes down on its own. See, this recording microphone level, it has become 65. I increase it to 100, but it still keeps going down. Okay, this thing I'll do next time then. I already have some questions. Let's look at that one.
Newton's law of motion.
Did you see this question?
Should I apply KVL, sir?
Yeah, first you have to understand the question. He's in steady state, no? So in steady state, what is the situation?
The current will not vary with the time.
So the current will not flow in this branch. Capacitor will,
Okay.
Cap-
That electromagnetic lesson, sir.
no, this is DC only. DC voltage only.
This concept is in electromagnetic only, sir.
No. This is just a capacitor circuit. Okay. So in steady state, the capacitor will act as an open circuit. No, it will be fully charged.
Sir, we didn't see that concept, sir.
Okay, do this one then. This is also RC circuit only. You have not seen the resistance and capacitor combined in a circuit?
No, sir, we didn't see that.
Okay. The capacitor C1 charge up to V and then connect to the uncharged capacitor C2. The final potential difference across each will be. So tie this one.
That's it. Sir, can you please send that either URL to my WhatsApp, sir? These are interesting. I have installed the app, but I can't see the previous.
Read from here itself. As soon as you read the question, you have to draw some figure. So to find this potential difference. So what is the constraint? What will change from here to here? From here to here, what will not change? Total charge.
That will be conserved.
So the initial charge here is C1 into V. So let the final charge here will be say Q1, Q2. So we have one equation, Q1 plus Q2 equal to C1V. Okay, so and Q1 plus Q2 equal to C1 into V, and the capacity is C1, right? So suppose the final potential is VF. That's the thing I have to find out. So Q1 is C1 VF, and this Q2 is C2 VF. So I have to find, okay, I studied what the answer. So VF equal to C1 V by C1 plus C2.
So I show me the previous picture one second.
So got it now?
Yes, sir.
Try this one. The conductors were very transmissible charge to micro. The other conductors were very transmissible about it. Touch it for some time, and then this place is separated. Okay, I think we just solved this problem.
Yes, sir. That is it.
Circuit. This is also a trivial question. C1, C4, C0 for each 4 microfarad. So how do you do this one?
Two is to one is the first one. And second one.
So how do you solve this question? You have to find effective capacitance between A and B, right? So between A and B, there are two parts. One is this one. Okay, the other one is this one. So this is a bridge, no?
Each 20.
Yeah, and the ratios are all the capacitors are 4. So is it a balanced bridge?
4. Yes, sir.
So this thing can be removed. Okay, so
4.
now C4 and C3 are in series. This are in series. So 4 and 4 in series is how much?
8.
No. Capacitor, no.
Okay. Okay. Yes, sir. 2.
And 2 plus 2 is
4.
so 3 is 2. And 3 capacitors, each of 4 microfarad are connected in such a way that the effective capacitance 6. This can be done. Okay, this is a good question.
Two in series and 1 in parallel, sir.
All 4, right? Effective should be 6. So it should be 2 if I connect in parallel become 2. No, 2 if I connect in parallel become 8. No.
No, 2 series, sir.
So if you
2 in
connect,
series and 1 in parallel.
so if you connect 2 in
2
series,
are connected in series. It becomes 2 microfarad. And is connected to another 4 in parallel means it will become effective of 6.
4 is 3. So this is a combination.
Yes, sir.
Understood the question?
Defibrillator means
This is a trivial question.
millisecond, sir, that one.
Yes.
Nineteen.
Try this one. C1, C2, C3 in series. And C1 is C2 is 2C, and this is 3C, and this guy is 4C. So all these things are in series means, so this is 6C by 6, this is 6C by 3, and this is 6C by 2. So this series combination is 6C by 11.
Yes, sir.
So this you have to add with 4C. 44, so 50 by 11. That is 25, 50 by 11.
Because after charge ratio only, sir.
Oh, find the ratio of charges in C2 and okay. Find the ratio of charges in C2 and C4.
Charge and series will be same only, sir.
Okay. Now I have to find how the charge is getting split. See the charge, the total charge here on C4, that is Q4, is 4C into B.
4. Yes,
Okay. And the charge here,
60 by 11 into B.
so the effective capacitance of this branch is how much? 60 by 11. Okay, so Q2 will be 6C by 11 into V. Because the charge in Q1, Q2, Q3 are same. That is same as the charge across these 2 points. So the effective capacity of these 2 points is 60 by 11. So charge across those 2 points 60 by. I have to find the ratio. So it will be 6 by 11 is to 4. That is 2 is to 22. Sorry, 3 is to 22.
3.
Got it?
Yes, sir.
Find capacitance each of this is also a trivial question. Got the answer?
2 is to 3, sir.
Capacitance between P and R. There is these 2 points. So it is C by 3 in series with C by 2. So they are added, no? Sorry, in parallel. So series means okay. In parallel means will get added. And capacitance across PQ. P and Q means will be C plus C by 4. So the ratio is 4 is to 6. Clear?
Yes, sir.
Mechanical capacity is charged and potential elements after disconnecting. Okay. You can do one thing. You can go in the reverse direction because these things are easy. Try this one.
First one, but I don't know what is displaced in current.
Understood the question?
Yes, sir, but I don't know what is displaced in current.
See, basically there will be charge flowing, right? From the battery,
Yes, sir.
and it will get, this thing will get charged as positive, and this thing will get charged as negative. So there is charge flow that's happening in this wire, no? Connecting wire. Understood, to this connecting wire, but in between there is a gap. So it's as if the current is flowing through this gap. So that's imaginary current. It's called displacement current.
Okay, but actually no current flow through that gap, no, sir.
Yeah. Actually, no current flows. Only the electrons will flow. So the electrons will flow in this direction. Electrons will flow in this direction.
Yes, sir.
Okay, because this thing will get negative charge and this thing will positive charge. So if I want to measure the current in this wire, it's as if a positive current is flowing in this direction. Okay, but here in between the place there is an imaginary current. There is no actual current. That is called displacement current.
Okay.
So this current will be same as the current that's flowing in the wire. So the current flowing in the wire is the rate at which the charge is getting built up. So I know Q as a function of time. Okay, from there I get current as 3C, that is 660 microamps. Okay.
Okay, sir. Okay, so always the displacement current will be like conduction current also will be same as.
Yeah, because whatever thing is flowing, see, if there is 2 electrons here, okay, then there will be plus 2 electrons here, no? So it's as if the electrons are going from here and it's coming back to this point. So it's as if the electrons are crossing this point.
there is no exceptional case for displacement conductivity.
This imaginary current is called displacement current.
Okay. This is true for all cases as well.
Yeah. Whenever you connect a capacitor to a circuit where the current is flowing external wire, so it assumes that this current is, because for a current to flow, there has to be a closed path, no?
Yes, sir.
So here the current is flowing without a closed path. That is because charge is getting accumulated here. Okay, so instead of accumulating the charge, if I connect these two by wire, the charge is flowing here. So that imaginary current is the displacement current. So always your displacement current will be same as the conduction current in the wires.
Yes, sir.
Okay, this just now we solved. Okay, try this one.
Electrostatic.
This is definitely true because there is no D here, no. This is false. Because the electric field here between the plates is sigma by 2 epsilon naught. It is independent of the distance between them. This is also not true. Okay, everything is false. Only 3 is correct. Got it?
Yes, sir.
See, the level goes down automatically. Spherical capacitor is not there for you, no?
No, sir.
Because it aims 2017, so I don't think it is there for you right now. Yeah, this is fine. 25. Try this one. This also may not be there for you. Okay, this is also RC circuit, so I don't think it is there for you. This RC, your mic is off. RC circuit is not there for you, no?
What RC, sir?
Resistance and capacitance connected in series. Aims to
electromagnetic induction like anything.
no, that will come in AC circuit, no? This
Ah.
this is DC only. Okay, but R and C are connected. So this is Ames 2017. Okay, leave that. Two parallel together, the separation between the liquidity are separated by a large distance, and the force of interaction between them is proportional. This is also a tricky question. Two charged parallel capacitor, which of separation? You are understanding this question?
No, sir. Okay.
Parallel plate capacitor, the separation is D. Okay, the force of interaction between them is, the way we find the force of interaction is electric field that is sigma by 2 epsilon naught into the charge, right? That is sigma into dA. But that thing is valid if the plate is infinite. Okay, and that infinite assumption is valid because if the distance between the two plates is very small. But here, after the plates are being separated, okay, then the distance between the plates is increased, so that assumption will not be valid.
Capacitor, please.
Huh?
Two capacitors.
Plates. No. Two plates. It's a single capacitor, only two charge parallel capacitors, plate capacitors. Okay, these liquidity are separated by a large distance L. For force of interaction between them.
You have to find force between two capacitors, not between two plates.
Two charge parallel plate capacitors. Separation by a large distance. Then the force of interaction between them. There would be interaction between them. Okay, this question is not clear.
Okay. You have to find the force between the two capacitors and not between two plates of the two capacitors.
The force of interaction between them. That means what? Interaction between the two capacitors. Okay,
not between two plates of the capacitor.
Yeah, leave it. According to me, there is no interaction. So this Ames 2017. The capacitor is charged by a battery. The battery is removed. Okay, this guy has given solution 23. So this one is given. He has not given solution. So 19 and then he has jumped to 28. Capacitor is charged by a battery. Battery is removed. Charge capacitor is complete. Okay, this is the same question. Decrease by a factor of 2. Okay, we'll close now.
Okay, sir.
Okay, so important things you have to revise. So at least the previous class, I've created this thing, right? So this you can use for revising. Okay.
For previous lecture,
Yesterday's class. Before that.
Yes, sir. Yesterday lecture. But
I'll create this timestamp. Okay.
Okay.
So for everything. So whatever I created, I send you a WhatsApp message. Okay.
Yes,
and then you can. This is also this better way of revising, because after going to the notes, if you don't understand, you have to come back to this one. So and this thing you can skip whatever you don't want. Okay, I give a brief description. Keystone bridge, water tank and your Keystone bridge, and then bridge balance condition, meter bridge. So whatever you don't want, you can skip. Just pick whatever you want. Standard result of series and parallel combination of resistances. Voltage division in direct ratio of resistance in series combination. So if you already know this, you don't have to go here. Okay. Okay then. So we'll meet tomorrow. 3:30.
That previous question linked to my WhatsApp.
WhatsApp I cannot send. I'll send you my mail.
Okay. Why, sir?
How do you send a WhatsApp from the laptop?
Okay.
From you open your mail on your mobile, and from there you can get it. Okay.
Okay.
Using laptop is easier, no?
Yeah, but I told you, no, sir, my laptop is restarting again.
Oh, that problem is still there.
I just reinstalled that Windows website.
Okay. So when if you're going to the guy for reinstalling, just ask him to install that software.
So
Okay.
after that software only my laptop shows the
No, no,
problem.
no, 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 no. This is a Microsoft software. It's not a. There won't be any problem with that. It's a software from Microsoft. Okay.
Okay, so you don't face any problem after installing the software in your laptop.
What?
Do you face any issue on your laptop after downloading that
No, no,
software?
no, no. That's what I'm saying. There's no problem with that software.
Okay.
Maybe you did some mistake in installing. My guess is if you're reinstalling, you have to uninstall first properly. Only after uninstalling, you have to reinstall.
Okay, sir.
Okay, then bye.
Bye.